In this last part of the topic, we will learn about the formulae in radian measure. Previously, we found out that the arc length of the sector is given by the formula theta over 360 times 2 pi r. Now, what happens if theta here is in radian? We cannot use this formula anymore, and since 180 degrees is equals to pi radian, 360 degrees will be equals to, yes, 2 pi radian. And if the angle here is in radian, we will need to convert this to radian as well, which will give us theta over 2 pi, because 360 degrees is 2 pi radian, times 2 pi r. 2 pi divided by 2 pi is equals to 1, and we are left with only r and theta, whereby theta is in radian. Therefore, to find the arc length of the sector, we can use the formula S equals to r theta, whereby S is the arc length and theta here is the angle in radian. Previously, when the angle here is in degrees, we found out that the area of the sector is given by the formula theta over 360 times pi r square. Now, since 360 degrees is equals to 2 pi radian, when the angle given is in radian, we will have theta over 2 pi times pi r square, which will simplify to half r square theta, whereby theta is in radian. You'll notice that theta and r square is at the numerator and 2 is at the denominator. And we can rewrite this form as 1 over 2 r square theta to give us half r square theta to find the area of sector. When the angle given is in radian, we will use the formula half r square theta to find the area of sector. If the angle given or the angle that you are finding is in radian, do use these two formula instead. Now let us find the arc length x, y, z. Since the angle subtended by the arc here is in radian, we will use the formula S equals to r theta, whereby S is the arc length, and we will have 12 times 1.74 to give us 20.88 centimeter. Next, we are asked to find the area of sector OXBZ. Since the angles are given in radian, we will use the formula area of sector equals to half r square theta. Now, what is the value of r and what is the value of theta for this major sector? Yes, the value of r is 12. Now, what about the value of theta here? We cannot use 360 degrees minus the angle here because 360 degrees is in degree, whereby 1.74 is in radian. And therefore, we will need to convert 360 degrees into radian. And we will have, instead of 360 degrees minus the angle, we will have 2 pi minus 1.74 radian to give us this angle here subtended by the major arc. And substituting in the values, we will have half times 12 square times 2 pi minus 1.74, which is the angle theta here. Pressing the calculator, we will have 327 square centimeters rounded off to 3 significant figures. It is important to stress once again that to find the angles at the points, we cannot use 360 degrees. Instead, we need to convert 360 degrees to 2 pi radian instead. Next, let's look at how to find the area of segments XYZ when the angle given is in radian. The area of the segment XYZ can be found using the area of the minor sector minus away the area of the triangle. Since the angle is in radian mode, we will use the formula half r square theta for area of sector. The area of triangle remains unchanged, which is half AB sine C. Now, since we have sine here, do remember to change your calculator to radian mode. Substituting in the values, we will have half times 12 square times 1.74 minus half times 12 times 12 times sine 1.74. And once again, make sure the calculator is in radian mode. And this will give us 54.3 square centimeters rounded off to 3 significant figures. How do we find the area of the major segments XBZ? We'll use the area of the major sector plus the area of the triangle. And since the angle is in radian mode, we will use half r square theta for area of sector. For the triangle, we will use half AB sine C. Now, what is the value of r, theta, A, B, and C? Yes, r will be 12 centimeters. Since we are finding the area of the major sector, we will need to find the angle subtended by the major arc. And to find this angle, instead of using 360 degrees, we will need to use, yes, 2 pi minus 1.74 because 2 pi is 360 degrees. The area of sector will be equals to half times 12 square times 2 pi minus 1.74. For the area of triangle, it will be half times the two given sides, which is 12 and 12, multiplied by the sine of the included angle, which is 1.74. And once again, make sure your calculator is in radian mode because we have an angle in radian. We will have 398 square centimeters rounded off to 3 significant figures. In summary, when the angle given is in radian, the formula for finding the arc length of a sector is given by S equals to r theta, whereby S is the arc length, r is the radius, and theta is the angle in radian. The area of a sector will be given by half r square theta. And that's all for this topic.